Myself Prayak Patel, working as an assistant professor in IT/ICT department of LG Institute of Engineering and Technology. Now in today's video lecture, I will explain a new chapter, unit number 5, greedy algorithm. Now in today's lecture, we discuss about the introduction of greedy algorithm. Now consider initially what is the greedy algorithm. To solve the problem, locally optimal decisions are made is called the greedy method. Means you can consider the locally optimal, not consider as a globally optimal solution. Here consider in greedy algorithm, the decision of solution is taken based on the information available. Means at the moment, at a time, you have a many options. Out of this available option, select the best option is called the locally optimal solution. You are considered as a greedy algorithm. Greedy algorithm always make the choice looks best at moment to optimize a given objective. Means for solve the any problem, consider the locally available solution, and out of this all available solution at the moment, consider the best solution, means consider as an optimal solution. So here the greedy algorithm doesn't always guarantee the optimal solution. However, it generally produces a solution that is very close in value of the optimal solution. Means greedy algorithm does not give the guarantee of find the optimal solution, but this solution considered as a near to optimal solution or closer to optimal solution. So this is called the greedy method. Now consider the greedy method. In greedy technique, the solution constructed through a sequence of steps. At each step, the choice made should be following properties. So here consider first one is feasible solution. For selecting the any solution, first consider the property of the feasible solution. What is feasible solution? Feasible means it should satisfy the problem's constraint. Here consider problem constraint means some condition. It should satisfy the minimum condition or minimum required, then it's called the feasible solution. For example, for consider the any problem like making change problem, you want to find the change for any number n, then consider the feasible way. For example, you want to make a change for 10, then feasible solution consider as a 1 coin of 10, then consider 2 coin of 5, then consider 5 coin of 2, then consider 10 coin of 1s. It's called the feasible solution. So available solution, possible solution considered as a feasible solution means it should satisfy the problem constraint. Okay, means satisfy the problem condition. Now second property is locally optimal. Now what is the locally optimal? Among the all feasible solution, the best choice is to be made. Means out of the all the solution, consider the best choice. Means for making the change for 10 rupees, you have a many solution, but which solution consider as a optimal solution, which is near to our goal state, consider as a optimal solution. For example, select the coin of tens or 1 coin of tens, consider as a optimal solution. Means locally optimal solution consider as a available all the solution. Out of this all available solution, select the best solution is called the locally optimal solution. Now next point is evocable. Evocable means once the particular choice is made, then it should not get changed on subsequent steps. Means for example, you want to find the change for 15, then you first select the 1 coin of 10s. After selecting that coin, you not change that coin further. So here consider one the particular solution or choice is made. You once select the coin of tens, then it should not get changed on subsequent step. Means after selecting any coin or after selecting any choice, you not change that choice or not move the in next step. So consider these 3 steps for understanding the greedy algorithm or how greedy algorithm will work. Now consider next topic as a general characteristics of greedy algorithm. Here in greedy method, following activities are performed. Now first step is first we select the some solution from the input domain. So here consider if you want to change or making a change for 15 rupees, then consider the first choice. Means you have a many coin. You have a coin of tens, coin of 5, coin of 2, coin of 1, like this. Many options are there. Out of these all options, select any one option. Means first you select any one coin. So that coin may be 1, maybe 2, maybe 5, or maybe 10. So first we select the sum solution from input domain. So out of all the possibilities, select any one coin of any one amount. Now next step is, then we check whether the solution is feasible or not. Means if we select the one coin of tens, then 10 is feasible or not. If you want to find the change for 15, then 10 is feasible. But if you want to find the change for 9, then 10's coin is not feasible, because you want to make a change for 9 and your coin is 10. So your coin is greater than your solution. So this consider as a not feasible solution. So first of all, you select any one coin, then check this coin is feasible for your example or for your problem. It's called the second step. Then we check whether the solution is feasible or not. Now third step is, from the set of feasible solutions, select the optimal solution. Means here consider for making change for 9. Then feasible solution consider as a coin of 5, coin of 2, and coin of 1. But coin of 10 not consider as a feasible, because 10 is greater than 9. So out of these three feasible solutions, select the best solution is called the optimal solution. Now fourth step is, as greedy method work in stages, at each stage only one input is considered at each time. Means out of all the possibilities, all the coin, at a time you can select only one coin of any one amount. Means one coin of tens, or one coin of 5, or one coin of 2, or one coin of 1s, like this. Based on this input, it is decided whether the particular input gives the optimal solution or not. Means after selecting that particular point or particular coin, solution is find or not, or optimal solution is get or not, is called the fourth step. Now consider the property of the greedy method. It's called the greedy property. Now it contains two properties. First one is greedy choice property. Now greedy choice property means it says that a globally optimal solution can be arrived at by making the locally optimal choice. Means globally optimal solution means what, and locally optimal solution means what? Locally optimal solution means at a particular moment or at a particular step, you have a many options. Out of this all options, select the best option. But globally optimal solution means after the find the locally optimal solution, final goal is find the globally optimal solution. When we find the global optimal solution means all the choice of the locally optimal solution is considered as a optimal. So here we can say that greedy choice property as a, it says that a globally optimal solution can be arrived at by making a locally optimal choice. Because when we find the global optimal solution, then each and every option must be optimal. So second property is optimal substructure. Optimal substructure means an optimal global solution construct the optimal solution of all its subproblem. Means here consider global optimal solution contain each and every subproblem, or here consider total our goal is find the change for 50. Then first one is select the one coin of tens, it is also optimal. Then consider another coin of 5. So these two choice, one coin of 10 and second choice is one coin of 5. Both the subproblem are optimal. Then we can say that the final solution is optimal. Now consider the next point. Here next point consider as a making change problem example for understanding the greedy method. Here consider the three type of coin are there. First is number of coin 1, means here total consider 6 coin of 1s. Second is many coin of 4, means here consider also for number of coin 6 coin of 4s. Then next one is 6 coin of 6. So you have a three type of coin, 1, 4 and 6. Now what is your goal? your goal is find the optimal solution. Here consider optimal solution means find the change for any number. For example, here we consider change for 9. So here if you want to find the change for 9, then which solution consider as an optimal solution? Means making a change for 9 using minimum number of coin. You can use the coin of 1s, you can use the coin of 4s, and you can use the coin of 6. But your goal is find the optimal solution, means consider the minimum number of coin required for change of 9. So here our question is how we can find the change of 9 using the coin of 1, coin of 4 and coin of 6. Now consider these three type of coin. You want to find the change for 9. Then what is the possibility? Here consider the first, you can select the any one coin of 6, then on any one coin of 4 or any one coin of 1s. But according to greedy technique means you can find the solution as a greediness. Here consider first choice, you have a three option, 6, coin of 6, coin of 4 and coin of 1s. Then out of these three, which coin is first selected? For that, you remember that your goal is for find the solution for 9. But you have a three choice, 1, 4 and 6. Then out of these three, which one is optimal? Locally optimal means initially you consider all the possibilities. You have all the three type of coins. So out of these three, which one is near to your goal state? Your goal state is 9. And here consider 1, 4 and 6 as a three type of coin. So near to your goal state or near to value 9 consider as a 6. So here consider 6 as a locally optimal solution. We already discussed what is locally optimal solution. So here at the moment you have a three coin. Out of these three, best coin consider as a coin of 6. So select the one coin of 6. So here remark the one coin of 6 is selected. Now for the next step, you want to find the change of 9. Now already you select one coin of 6, means already 6 is done. Now another coin is selected, which means here consider coin of 1 or coin of 4 or coin of 6. So initially you check the best solution, means locally you consider the another coin of 6. But if you select the another coin of 6, then total equal to 6 plus 6 equal to 12. And 12 is greater than 9, so here not select the another coin of 6. Only we select one coin of 6. Then here consider not select the another coin of 6. Now after the 6, we consider the minimum amount consider as a 4. So next time we check for value 4 because 6 is not feasible. So now consider another choice is 4. If we select the another coin of 4, then what is the total? Already 1 6 is selected, means 6 plus 4 equal to 10. Then 10 is greater than our optimal solution 9. So our making change solution for 9. So here consider greater than value of 9 equal to 10. So here consider 6 plus 4 equal to 10. So no need to select the one coin of 4. So here cancel your choice 4. Now if we select coin of 6, then not feasible. If we select the coin of 4, then not feasible. So here remember the point of feasible solution. Feasible means possibility of solution. Now check for another coin. Another coin is last coin number 1. So select the one coin of 1s. So here possible 6 plus 1 equal to 7. Yes, less than 9. So we select the one coin of 1. Then another coin of 1. Yes, select because 6 plus 1 means 7. 6 plus 1, 7 plus 1, 8. So here next one is another coin of 1s, because each and every time you check for 6, then check for 4, then check for 1. But you start the checking from highest number. Highest number means near to your goal state. So here consider choice of 6, then 1, then 1, then 1. Means total number of coin required equal to 4 number of coin. Because 1 coin of 6 and 3 coin of 1s. So total number of coin required for making change for 9 equal to 4. Now we already discussed the one point. Greedy algorithm not guarantee for find the optimal solution. So here we check this solution is optimal solution or not. This is called the locally optimal solution, but this solution considered as a globally optimal or not. For that we consider best solution or better solution for this problem. We have already 1, 4 and 6 coin. Now for making change of 9, what is the possibilities? Which solution considered as a feasible solution? So first feasible solution as a, if we select 1 coin of 6, then 3 coin of 1s. So total coin required equal to 4 and here total value equal to 9. Now consider another possibility, 1 coin of 4 and remaining all coin of 1s. So here consider total 6 coin because 1 coin of 4 and 5 coin of 1s. Now another possibility is 2 coin of 4 and 1 coin of 1. So here consider possibility for first option is total number of coin required equal to 4. In second possibility, total number of coin required equal to 6. And in third possibility, total number of coin required equal to 3. So here which one is best solution or optimal solution? Third option, 4 plus 4 plus 1 means 2 coin of 4 and 1 coin of 1 is called the best solution, means we can say it's called the optimal solution. So in grid, according to greedy method, we select the first choice, means 6, 1, 1, 1 is called the answer of the greedy choice. So in greedy method, we find the solution as a 4 coin, but best solution or optimal solution as a 3 coin. So here consider greedy method not gives the optimal solution each and every time. So here consider this example for understanding the what is greedy method. Now difference between dynamic programming and greedy method. Consider the table of the difference between dynamic programming and greedy method. We already studied the dynamic programming in our previous chapter, and in this chapter we study greedy method. So here first difference is dynamic programming is used to obtain the optimal solution, as well as greedy method also used for find the optimal solution. So here consider first point as a find for optimal solution. Now second point, in dynamic programming there is no special set of feasible solution, but in greedy method there is a set of feasible solution, and out of all the feasible solutions select the best solution, means optimal solution. So here consider as a set of feasible solution in greedy method. Third point is dynamic programming consider all the possible sequence in order to obtain the optimal solution, means in dynamic programming we consider each and every option and put the answer of each and every option into one table, and after that backtracking process is done and find the optimal solution. So here consider this point as a for find the dynamic programming. Now in greedy method, third point is in greedy method the optimal selection is without revising the previously generated solution. In dynamic programming we consider previously find solution, then find the next solution, then find the next solution, like this. In greedy method, no worry about the recursively find the previously generated solution. Now fourth point is example of dynamic programming is 0-1 knapsack problem, and in greedy method example is fractional knapsack problem. Now last point of dynamic programming is it is guaranteed that the dynamic programming will generate an optimal solution using principle of optimality, means dynamic programming always give the optimal solution. Now in greedy method there is no such guarantee of getting the optimal solution. In some case greedy method gives the optimal solution, but not guaranteed that each and every time give the optimal solution. For example, our previous example coin of 1, 4 and 6, if you want to find the change for 9, then not give the optimal solution. But if you want to find the change for 7, then you first select the 1 coin of 6, then next select the 1 coin of 1s. So 2 coin required. According to greedy and according to dynamic, both the case consider the 2 coin as your solution. So this is considered the optimal solution. Now another difference is difference between dynamic programming and divide and conquer technique. We already studied the divide and conquer technique in unit number 3 and previous chapter consider dynamic programming. So here first point in divide and conquer technique is it deals with 3 steps of each and every level in divide and conquer technique. So here 3 steps is first step is divide, second step is conquer, and third step is combine. So here what is divide? Divide means divide the problem into sub problem. Then conquer means recursively find the solution or solution of the subproblem. And third, combine. Combine means after solving the each and every subproblem, combine the result of the subproblem. It's called the divide and conquer technique. In dynamic programming, it involves the sequence of 4 steps. First one is characterize the structure of optimal solution, means derive the equations. Second step, recursively define the value of an optimal solution. Third step is compute the value of optimal solution in bottom-up fashion. And fourth step is construct an optimal solution from the computed information. Means in dynamic programming, you solve the problem according to this 4 steps. Now second point is in divide and conquer technique, it is recursive, means recursively find the solution. In dynamic programming, it is not recursive. In divide and conquer technique, it does more work on sub problems and hence has more time consuming. Then in divide and dynamic programming, it solves the sub problems only once and then store in the table. Means already we study the dynamic programming. In dynamic programming, you find the solution of the sub problem and store the result into your table. So this is more effective, consider as a dynamic programming. Now first step is it is a top down approach. Divide and conquer technique is a top down approach. First we divide the problem into sub problem like this. And dynamic programming consider as a bottom up approach, because using backtracking method we follow the bottom up approach for find the solution. Now fifth point is in this sub problem are independent of each other. Divide conquer problem is independent to each and every. Then in dynamic programming, in these sub problems are independent. Okay, and last point of divide and conquer and dynamic programming is here consider the example of divide and conquer technique is merge sort, binary search like this. And in dynamic programming, consider the making change problem, longest common subsequence like this. So here in today's video lecture, we consider the difference of divide and conquer and dynamic programming and greedy algorithm. So here consider many problems can be solved using greedy algorithm. So here only list out of all the problem which problem can be solved using greedy algorithm method. Means in this chapter we study this type of problem. First one is knapsack problem. Second one is job scheduling with deadline. Third one is activity selection problem. Next problem is Prim's algorithm for find the minimum spanning tree, and another algorithm for minimum spanning tree is Kruskal's algorithm for minimum spanning tree. Sixth problem is Hoffman code, and here consider last problem as a single source shortest path. We already discussed how we can solve the or use the greedy technique for solve the problem. According to this technique, you can solve this type of problem using greedy algorithm. So in this chapter we study each and every problem one by one in our next video lecture. Thank you for watching this video.